The James Webb Telescope keeps digging into our universe's secrets, and it seems like it won't stop anytime soon. One of its most powerful features is seeing back through time at the furthest distances of the universe. The first few 100 million years after the Big Bang remain the most unexplored parts of the entire universe, but fortunately, the highly equipped telescope James Webb is already on its way to change that. Provided with the most sensitive infrared sensors, it made multiple astonishing discoveries so far, but today we will be talking about the Schrodinger's galaxy candidate. The Schrodinger's galaxy is one of the scientists' favorite topics. This galaxy behaves differently than any other galaxy, and that is because it seems to be at two different places simultaneously. So what is so strange about this galaxy? Why does it behave this way? And finally, why is it considered the strangest galaxy found by JWST so far? Stick with us as we dive into the topic. Ever since the universe's beginnings, light and sound traveled in waves. To understand what this means, we are going to explain a phenomenon which is called redshift, and it is used by scientists and astronomers to determine how far away objects or entities really are. In order to understand how redshift really works, let's take the following example. Have you ever noticed how the sound of an ambulance's siren changes when the ambulance passes you? This happens because if the ambulance is moving, the sounds in front of it are compressed, and that creates a higher frequency sound. If the ambulance is moving but the sound waves are behind, then the sound waves are stretched, and that creates a lower frequency sound. This is called the Doppler effect, and this is the reason why the sound of an object changes when it's passing us. The same happens with light. Light waves are able to be stretched and compressed just like sound waves. With sound, the frequency changes, but with light, it's the color that changes. If an object in space is moving towards us, then light waves are being compressed, so the light becomes blue shifted. If it's moving away from us, then the light becomes red shifted. This is such a powerful measurement calculation, since astronomers can use it to determine how far away a galaxy is, just by using redshift. The most common way scientists determine the redshift of a galaxy is to analyze the galaxy in different standard filters, denoting the redshift by a dimensionless quantity z, which represents the time. Z indicates how many years the object's light took to reach us, but this is not the object's distance in light years, because the universe has been expanding since the light's arrival, making the object much further away now. Here is an image with some z values, so you can make an idea about how much time light travels for the followings. The maximum z value that you have seen on that table was 10, and that is because astronomers never discovered a galaxy that had a greater value than 10, until 2015, when Hubble took its first glimpses on a galaxy called GNZ11, that has a z equal to 11.1. Hubble is limited when compared to James Webb. Hubble can look back up to 500 million years after the Big Bang, while JWST can look back up to 200 million years after the Big Bang, meaning that the JWST can give us views of a z greater than 13. However, astronomers didn't expect to discover a galaxy that has a redshift of z equals 17. This candidate is called CIR 1749. It's an insanely bright galaxy that existed only 220 million years after the Big Bang occurred, and it may also rewrite our understanding of the universe. CIR 1749 could be one of the furthest galaxies ever discovered, or it could be much closer. The data that has been analyzed by a team of researchers seems to indicate that this galaxy is being located in two different locations at the same time, and this is the catch that keeps astronomers awake at night. But why is CIR 1749 referred to as the Schrodinger's galaxy? The James Webb Telescope's observations suggest that the galaxy is located at a redshift of around 17, but there are also high probabilities that it could lie at a redshift of 5, indicating that it could be located in two different places at the same time. This is the reason why it has been nicknamed the Schrodinger's galaxy. It's an analogy to the famous thought experiment called Schrodinger's cat that illustrates a paradox of quantum superposition, in which a cat is both alive and dead at the same time until you observe it. Sears 1749 is estimated to have an insane mass of 5 billion solar masses, which makes it a supermassive galaxy. The Sears 1749 galaxy also has an astounding paradoxical result that shocked scientists. Despite being extremely far away, it appears to be lurking much closer to us. Astronomers are still investigating the strange feature, and they anticipate that with some observation, an explanation will become clearer. The Sears 1749 galaxy is described as a Schrodinger's galaxy candidate in a paper that was uploaded to the preprint repository on the 4th of August because of its paradoxical nature. But redshift is the only explanation that can be offered at this time. We all know that the James Webb Telescope is completely different than Hubble, having more powerful capabilities. One of them would be the ability to see beyond the visible light range, so we can assume that the redshift can be the cause of this strange feature. Because Sears 1749 is considered an early galaxy, let's examine what early galaxies actually say about the universe. Many of the papers that have been published so far state that if their findings are confirmed, they will challenge the standard model of cosmology. The universe's evolution, according to this model, is governed by dark energy and the equally mysterious cold dark matter, or CDM, which accounts for nearly 85% of all matter. According to CDM, the first galaxies may appear as soon as 200 million years after the Big Bang, but they will be small and faint, resembling small dwarf galaxies. Instead, some of the distant candidate galaxies in the Webb data appear to contain about 1% of the mass of our Milky Way galaxy, which was quite a lot at the time. The discovery of a galaxy at such a great distance breaks the record set by the HD1 object in April 2022. Recent observations by James Webb and other telescopes have revealed very distant galaxies such as HD1, GLES Z13, GNZ11, and many more. The presence of so many distant galaxies contradicts models of the universe's evolution after the Big Bang, as well as the distribution of its distant galaxies in the celestial vault. I would be disappointed if they could explain all of Webb's observation with current physics. This is why the telescope is out there, to challenge our understanding and reveal new unimaginable truths. The learning will never stop, and hopefully, we will discover even more mind-blowing things that lie within the universe. Thank you for watching, and if you enjoyed the video and don't want to miss out on any future content, make sure you like, subscribe and click the notification button.